Hello, Mr. Betts here. So in this example, we have a parametrically defined system of equations that's going to give us a curve in the xy coordinate plane, and we want to find the second derivative. So if we want a second derivative, we're always going to start with a first derivative. So to find the first derivative, dy dx, we're going to take dy dt divided by dx dt. So let's go ahead and take derivatives of each of these equations by themselves. For the x equation, we're going to get dx dt, which could also be written as x prime of t. Okay, either notation would be acceptable. This is indicating that we're taking the derivative of x with respect to t. And that's going to be cosine of t. And the derivative of y with respect to t, which we could also write y prime of t, is going to be just e to the t, because the derivative of e to the t is e to the t. So we're taking these derivatives with respect to t, and then to get the first derivative, we're going to divide dy dt by dx dt. So we can remember which one goes on top because we're trying to find dy dx, which means we want the derivative of y on top. So this is going to be e to the t over cosine of t. So then to take the second derivative, we're going to take the derivative of the first derivative. All right, so to do that, let's first get the notation right. We are going to have to take the derivative of this expression with respect to t. But I'm keeping in mind that we're actually taking the derivative with respect to x, and that t is going to be treated as an inner function with the chain rule, and we're going to have to account for that at the end. But to take this with respect to t, the derivative here, we're going to have to use the quotient rule. So it's going to be the derivative of the top times the bottom minus the top times the derivative of the bottom. Derivative of cosine is negative sine. So I'm going to just change that to a plus, and then all over the bottom squared. All right, so I'm not done yet, because what I just did is I took the derivative with respect to t, but I want the derivative with respect to x. So to account for that, essentially what I'm doing is I'm multiplying by dt dx, but I know what dx dt is, and so I'm going to divide by dx dt to effectively do the same thing as dividing by dt, or I'm sorry, multiplying by dt dx. So this whole thing is going to be divided by dx dt, which is cosine of t. Now, if I'm dividing by cosine of t, I already have a fraction. So in order to divide by that, I can instead just multiply the denominator. And so what we end up with then is you can factor the e to t or not. It doesn't really matter. I'm going to do it just to save a little bit of time. And then on the bottom, we're going to have cosine cubed of t. It would be perfectly acceptable to go straight to cosine cubed of t in the denominator if you're thinking ahead and you know you're going to end up dividing by dx dt. So our second example is really similar. Same idea. We have the system of parametric equations defined for us here. We want the second derivative, so we'll start with the first derivative. So we'll have dx dt is equal to 2t. We'll have dy dt is equal to 1 over t. So dy dx is going to be dy dt, 1 over t, divided by dx dt, which is 2t. And so we're going to get 1 over 2t squared, which for taking the derivative, I'm going to rewrite as 1/2 t to the negative 2. So then second derivative, we take the derivative of the first derivative. So using the power rule there, we're going to have negative 1t to the negative 3. And then we have to divide by dx dt. And again, dividing is the same thing as just multiplying the denominator. So times 2t, and our second derivative then is going to be negative 1 over 2t to the 4th.